Thank you. It's a tremendous pleasure and joy to be here at the opening of the center. I'm just so happy to be here. And today, what I'm going to talk about is market design. And I'm going to relate it to conflict and cooperation because essentially that's what market design is balancing that tension between conflict and cooperation through proper design of the market rules in order to achieve the objectives. This will be a whirlwind. We actually, 2 months ago, we had a course, an intensive course, a week long that I did jointly with Axel and Alex, who's also here, and for the PhD students, and it was really wonderful, and the topic was market design. So this is very much joint work that I'm talking about, and many of my collaborators are here, and some are elsewhere as well. So to focus on conflict and cooperation, or tie this to conflict and cooperation, let's look at a German spectrum auction that took place in '99. This was for 10 identical blocks of spectrum. The auction was conducted simultaneously. It was a simultaneous ascending auction. The particular rules were that you bid for the individual blocks, and if you're going to place a new bid as the prices ascend, it has to be at least 10% higher than the prior bid, the standing high bid. The auction ends when nobody's willing to bid higher on any of the blocks, and it simultaneously closes. So, what happened in this auction? Well, so here's our 10 blocks across the top, and the rounds, 1, 2, 3, and going on potentially forever. Sometimes these auctions last very long. Italy had one that lasted 457 rounds. So let's see how long this one lasts. So here's the first round, and Mannesmann is one of the large incumbents in the industry, and they bid very strongly on all 10 blocks. So just to give you a little perspective, these are bids in millions. The blocks are each worth, they're all identical, and they're worth many hundreds of millions of dollars. Okay, just to set the stage. So this is kind of a funny thing that they were the high bidder right off the bat across all of them. The reserve price, the starting price, was almost zero. But it's also an interesting configuration of the bids because there's 5, just 10% less than 40. And then the remaining are 40, except for the last one, which was a bit higher. Now, this can be interpreted by almost anybody. I suspect everybody sees this as an offer to the other large bidder, which is T-Mobile, and basically saying, we got 10 blocks, they're identical, we're both big guys here, let's split them 50-50. I'll take the 5 on the right, you take the 5 on the left. They're all identical, so it doesn't make any difference. So T-Mobile in round 2, management doesn't place any bids. T-Mobile bids 40 on the first 5 blocks. Okay, so now we've got some competition going here. Let's see what happens next. No more bids. Auction over. So this is what this illustrates is not competition, but cooperation. In fact, management and T-Mobile engaged in perfect cooperation. And in fact, it was the market rules that led to this cooperation and the market structure, the fact that there were 2 guys competing for 10 identical licenses. But the market rules were very important, and the definition of the product that they were bidding on, making it 10 identical items when you've got 2 similarly sized and placed companies competing for what's available, is quite apt to reach this outcome. Now, I don't know what the intent of the regulator was, but this is a predictable result in this setting. And so if their goal was to identify the market price for the scarce resource or to allocate the scarce resource efficiently, this didn't do it. So it's not revealing pricing, and the 5-5 split, maybe that's consistent with economic efficiency, but I don't know. The auction didn't reveal it. So the theme of my remarks today are going to be that market design is all about looking at the goal that you're trying to accomplish and then design the market rules to induce that goal. In order to do that, we have to understand how people behave, because it's people that are participating in these markets. And so, as an economist, of course, I start with the people are rational, and they have some objective, and they seek to maximize it. But as a person, I know that that's not how they actually act. And so I have to think more broadly about what their behavior is apt to be, and then design the market rules to achieve the goal given the actual behavior that we expect. So this is what market design does. It establishes the rules of market interaction. It is intensely interdisciplinary. It's sometimes referred to as economic engineering. And just like when you're building a house, you could have the world's best plumber, and you might not end up with the best house. You need a good plumber, a good electrician, a good carpenter, all these things. Market design is about solving real problems in real markets for real people. And to solve real problems, you can't just have a single narrow discipline that nails the problem. The problem is too complex and too broad. And so market design is drawing on economics and our understanding of incentives, computer science to solve computational problems and understand algorithms, operations research to develop algorithms that can solve complex optimization, psychology to understand human behavior, and typically, depending upon the circumstance, engineering will play a very important role, whatever the context is. In communications, then it would be communication engineers, or in transportation, it would be transportation engineers, and so on. So it's intensely interdisciplinary in a really wonderful way, and this is why I enjoy market design so much, because the disciplines are coming together to solve real problems. Some of the accomplishments of market design are listed here: better allocations, better pricing, reduced risk, greater competition, mitigating market failures, and so on. There are lots of applications. Many of the applications can be broken into two categories: matching, I give a number of matching problems there, and then my main specialty is in auctions, and so that's what I'm going to focus on for the rest of my remarks. And I'm actually going to talk about many industries: electricity markets, communication markets, transportation markets, financial securities. And when I talk about electricity, I'm going to diverge and talk about climate policy and how we can make Paris work and promote cooperation in international climate negotiations. So it's quite a bit of stuff, and I'm going to go through it, and it'll be rather impressionistic, but hopefully you'll get an idea that there is some discipline here, and we can actually, by developing knowledge, we can make markets better, which is going to be very good for all of us. Now, that's a rather bold claim, but let's look at the individual applications that I'm talking about and see what is required to make the markets work much better. And the remarkable thing is a lot of the solutions are obvious. Okay, which would, then why don't we do them? Well, the reason we don't do them is because there's special interests that want to do something else, like the status quo typically, and they benefit from the status quo. And so it's very difficult to move to obvious solutions. And each one of the other things I like about market design is I can explain it to my mom and my dad and in just a few words, and my brother and sister and their children and my nieces and nephews and so on in just a few words. And they all get it, and they actually think, geez, it's understandable, and it sounds pretty neat. So electricity, the key innovation here, now this isn't a market so electricity, when I'm talking about electricity market design, I'm talking about the wholesale market. And the wholesale market is not something the consumer experiences, but it is something it's a very important, complex market. And the key idea that makes electricity markets work, where they do have restructured markets, is open access. The fact that no one can withhold transmission capacity, that turns out to be key to the electricity market, and it's incredibly complicated time and locational market. We have to balance supply and demand in real time at every location, and that turns out to be a principal market rule that makes everything work. Another simple idea is pay for performance in electricity markets. And that should be obvious from anybody that's done contracting. Well, of course, you write the contract and you get paid if you perform. And what you're doing is something that people value. Well, there's a lot of electricity markets where that rule was not followed initially for certain important products, and it created a lot of problems. But now it's well understood that this is very important to design the products so it's something that's valuable for consumers, and to then pay suppliers based on performance. Communication markets, the first few words to describe the transition of communication markets to what we have today is this idea of auctioning spectrum. And I'm not going to say any more. I gave the one example, but no more on spectrum auctions. But this is that was a good start, which that led us away from the monopoly telecom utility. But what I'm going to talk about later is bringing this open access idea to communications. And just like it transformed electricity markets, it can also transform communication markets. Transportation, I'm going to say something very similar, just very briefly in a few words, that essentially what we need to do there is price congestion. That this is the ingredient that's missing from current transportation markets. Essentially, transportation markets barely exist. Nothing is traded. It's just you show up on the highway and there's a bunch of other people and it's really annoying. Climate policy, I can do in 2 words. Price, carbon. It's that simple. Those 2 words. If Germany did this, then you would save hundreds of billions of euros. Okay, it's a big deal. And you would accomplish much, much more. Financial securities, this one's a little trickier for those that are not familiar with finance markets, but it's essentially make time discrete. That the current market rewards speed. And so what we have is this incredible competition for speed. And this is back to this tension between cooperation and competition. When you do, competition is an incredibly important force of markets. It leads to innovation, it leads to desirable services. But what you need to do in market design is to structure the rules so you get effective competition. Nobody cares about speed when we're talking about microseconds or nanoseconds. Okay, that was a quick overview. What's the big, now why, if this is so obvious, I said it's special interests, and this puts it here. You know, when I go to talk to the financial regulator about this stuff, I can save you $10 billion. The Wall Street is right there in the room, outnumbering me, saying, hey, that's my $10 billion. So it's definitely a problem. Here's a famous quote from Milton Friedman that describes this tyranny of the status quo. It really is a serious issue. And so, but his conclusion isn't that, well, you know, it's hopeless, so you just have to put up with it. It's, no, there's going to be events. There will be crises. There will be opportunities with which to institute change, and we need to be ready with our plans, with our good ideas, to unfold them and let them carry the day. And I've experienced this in a number of areas, and I think if I live long enough, I will see success in all these areas. But it's going to take time. Okay, these are things that are very simple, but it's change occurs in decades. Market design is not something that is, I mean, I guess it used to be a pretty odd duck sort of thing to do, but now it's becoming more and more mainstream. If you look at recent Nobel Prize winners in economics, they're from a variety of areas: game theory, behavioral and experimental economics, but also market design. And all these are very much connected. It's true that there's not market design types at all universities. There certainly are here at Cologne, and that's a good thing. And there certainly are a lot of them at Stanford, and Harvard's has a senior recruitment for a market design person now that Al Roth left. And so it's the very best institutions do have this as established area. Market design starts with the objectives. What are you trying to accomplish in the market? And the objectives that I focus on are the economist's favorite: efficiency, simplicity, transparency, and fairness. And I suspect all these objectives resonate. And the nice thing about it is, in lots of environments, these are not sharply conflicting objectives, but we can come up with designs that actually do score very well on all four of these dimensions. And that's what you're looking for as a market designer. So I always keep these in the back of my head. Now let me turn to the applications. And as I said, I'm going to focus on the ones in italics: electricity markets, and then I'll diverge into climate policy, then communications, then transportation, and finally financial markets. So electricity. This is a view of the control room at ERCOT, which is the Texas system operator. And just as an example, I just heard this command room because I joined the board of directors a few months ago, and it is an incredibly complicated market. There's a number of people here making sure the market's working as it should be, and normally they're just sitting there and everything is wonderful, and on occasion some strange stuff will happen. But this is sort of the front office. What's happening in the back office? The back office is a server farm. In fact, 2 server farms that are independent that have literally thousands and thousands of servers that are doing combinatorial optimization to make sure that the right units are generating the right amount of electricity at the right time and location. And that is and the market every 5 minutes is delivering prices for the most important product, which is energy, on a locational basis. Okay, so there's literally thousands of prices every 5 minutes at every location in Texas. Texas isn't alone. All the US markets, this is our standard market design. All the US markets are like this. It's incredibly efficient. It works really well. Europe is not quite there yet, but their market is improving and will continue to improve. But it's a very interesting area. There's a lot of engineering and a lot of rationality in this market. Now, there's still humans, and actually where the humans play the biggest role is on the retail market. You and me in the home. And so I think that that's actually the bigger area for the psychology part is at the retail level, where you're dealing with lots of humans, as opposed to this, where you're dealing mostly computers. So the purpose of the market, I said start with the goals, are very straightforward. First, short-run efficiency, generate the electricity that's needed at least cost. That's actually a fairly easy problem. It involves a lot of combinatorial optimization, but fairly straightforward. Then there's long-run efficiency, which is the tough problem. And this is where the real value of restructuring the markets is. This is trying to get the right mix of resources and quantity of resources in the right locations. And for that, you have to send the right long-term price signals. So long-run efficiency actually builds from short-run efficiency. And what has happened in these markets, as I mentioned, the key idea is open access. But what we see in these markets is it was necessary to define a number of products that are interrelated, and most importantly, have a number of opportunities to trade. Because that enables the parties to see the spot price when stuff happens, units trip, lines go down, demand surges for one reason or another. So you need enormous price volatility to induce the behavior that's necessary to keep the lights on in the spot market. But you need medium-term and long-term markets to support the investments, and that is accomplished by managing risk. And of course, market power is a big thing here as well. But so it's really this portfolio of markets that is needed to solve the problem. And it is quite a difficult problem, but it's an extremely well-developed, especially in the United States, well-developed time and locational market. And what it does is it demonstrates it's possible to do this, even in an environment where there's enormous challenges. You have to satisfy all these laws of physics. It's kind of annoying, at least for politicians, but it's true. So now, in terms of getting the right mix of resources and thinking about long-term investments and generating assets, one of the first things you need to do is figure out what the price of carbon is. And this is the problem with the current policy. One of the big problems is that our current climate policy isn't sending the right price signals. The price signal needs to come from a carbon price, and the world overall right now, the carbon price, it's barely positive. And it's enormously variable. Even within a country, it's enormously variable, right? Fuel for the car is highly taxed, and other uses of fossil fuels are actually subsidized, depending upon the country. So this work, which is a very large project, but it's summarized well in this 2-page paper that came out in Nature, is very much with Axel and my other collaborators here. And again, it's a very simple idea, but the basic idea is, let's use the problem that we have with climate policy at the international level is cooperating. Okay, so what we want to do is foster cooperation. Does science tell us anything about how we encourage cooperation? Well, of course it does. Everyone in this room has been involved in that research. So let's use that research to inform how we can promote cooperation in the international negotiations, for example, in Paris. So it seems rather obvious, but you'd be surprised how hard it is to convince people to move in this direction. And the reason you want to focus on the price of carbon is it's a direct instrument, it's an efficient instrument, okay, it leads to efficient abatement, and it's transparent. Okay, and what we're adding to the debate is, in fact, pricing carbon will promote international cooperation, and that's what's missing right now in the international negotiations. So what do we learn from the science of cooperation? We learn that a common commitment is incredibly important. I will if you will. We learn that it's actually incredibly helpful if you're negotiating over something you don't disagree radically about, okay, which would be the price of carbon. We don't radically disagree about the price of carbon. We radically disagree about how money should be split among us. Okay, there we've got intense disagreement, but not on what the carbon price should be. And then, of course, we have to address the enormous asymmetries among countries, and so some green fund is required that addresses that. But basically, you can keep this, what they're negotiating over, very simple, and this is going to, I'm sure, connect with some of the things that Adam is going to be talking about in a moment. So this is very much ongoing effort. We do not anticipate that Paris is going to make this research obsolete, but we'll see. We certainly hope that it does, but our expectations are lower than that. Okay, now let me turn to communications. So the future of mobile communications, because all communications now, mobile is certainly the big part. Well, what's happened in communications? We started with monopoly utility. It was Ma Bell in the United States. When we moved to wireless, then we switched to oligopoly. So we have these spectrum auctions. Infrequently, every 10 years or so, there'll be a big spectrum auction. And now we've got an oligopoly where there's typically 3, maybe 4 players in any particular market. And the problem with that is there's limited competition. And especially in markets like Germany, where you've gone from 4 players down to 3 players, competition is even less. And the UK now has a proposed merger to take them from 4 to 3. So the idea here is, well, let's do what we did in electricity. We can make this a time and locational market. Let's just introduce a network separate from T-Mobile's network and Vodafone's network that operates under an open access provision. That you can't withhold network capacity in the spot market. Essentially what that does, that single idea, transforms competition in mobile communications, essentially creating an internet ecosystem of innovation where the entry costs are more like $25,000 to enter Germany as opposed to tens of billions of dollars. It's a pretty radical change. The market model is described here. It's just like wholesale electricity market. We have a wholesale mobile communication market. It consists of this open access network and then the proprietary networks like T-Mobile and Vodafone, and then the service providers, which the consumer picks, compete for users, all these different users and devices in the retail market. So very simple idea. How do you find prices and allocations in this market? You cross supply and demand, which is what economists love to do, and it is literally this simple. Okay, this is the difference between communications and electricity. In electricity, we have to do combinatorial optimization because there's all these non-convexities and so on. In communication, there's none of that. The problem is linear. We just cross supply and demand at every location, at every time. We're done. We've built a prototype. So we're set to go here. This is the bidding screen in the monthly market in Manhattan. This is going to be rolled out first either in Mexico, in the United States, or in Europe. depending upon how things play out. The likely rollout in Europe would be through the UK as a merger remedy in the case of the 4-to-3 merger. And so Europe could actually jump on board pretty quickly, and that would actually be a very positive thing, I think, for Europe. So hopefully there'll be some competition there. But this is basically how complicated the market is. Again, drawing on the insights from electricity, we have a number of opportunities to trade. There's a yearly market, a monthly market, and then an hourly market. Let me say one more word, since I said the future of mobile communications. The future is now. There's nothing that we can't do right now. With the technology that's all in your phones, the LTE technology, it works. It's an incredibly enabling technology. And every carrier around the world is using it, or will be using it by next year, if they don't have it yet. So it might sound like wow, that's way too radical, but it's actually possible. So now let me turn to transportation, which has this problem of congestion. And now this might seem really radical to you, but, and this one is farther out. But essentially today, we have the capability to know the location of every device within a cubic meter. So that means I can have real-time pricing of every lane of every highway. And in fact, we've got the computational power now, which is just growing with Moore's law, to schedule transport. So what would congestion look like in a world where you're scheduling transport and you're using congestion prices? There is no congestion. Congestion doesn't exist. So it is incredibly radical, but it's doable with today's technology. It's going to take 10, 20 years to get this one done, but this will happen. It'll happen in my lifetime. 20 years from now, the kids will be laughing about, people drove a car because the cars won't be driven by humans. And it's actually humans that make car driving difficult. You take the humans out, and it's actually pretty easy to program the computers to do the driving. My last industry, finance. So financial securities are traded now by computers. The humans are gone. The humans program the algorithms that run on the servers. Okay, that's how it's done. This actually is, this is the New York Stock Exchange. This is where the trades take place, which looks like any other server farm. And that's the way it is. Now, why do you need all those servers? It's because every trader has to have a server that's co-located with the New York Stock Exchange. And that's true of all the exchanges. And it's pretty much true around the world. Okay, so this is New York Stock Exchange leasing the space to be co-located with the exchange. And actually the exchange is a single thread of a single core of a single computer, because it does absolutely no computation. I'm not sure that's true at NASDAQ. It's true I'm not sure it's true at New York Stock Exchange, but it's definitely true at NASDAQ, which is among the largest exchanges in the world, so I suspect it's also true New York Stock Exchange. Now, why do we have this? Well, a paper just came out in this month's QJE, which is described here. And essentially it is, the market today operates in this fiction of continuous time. Essentially, parties are rewarded for being fast. You get a big prize if you're fastest. So guess what that does? It induces an arms race for speed. And guess what? Who bears the cost of this? Well, in equilibrium, it's the fundamental investors. It's you and me and our retirement savings with Vanguard or Fidelity or whoever. There is a solution to this. which we propose in the paper, and we've got the empirical analysis demonstrating the arms race, and then theoretical analysis that shows enables us to understand why things are the way they are currently, and then understand what the implications will be if we adopted the solution, which is simply making time discrete, which is having frequent batch auctions. So every 1/10 of a second, we hold an auction, and cross supply and demand. And that's how that works. So extremely simple, direct solution to a market problem. What that does is it transforms the competition for speed into competition on price, and also competition on smarts. It has enormous computational benefits for the traders that can hear a piece of information that's relevant to prices and think. It can do hundreds of billions of calculations in a 1/10 of a second and come up with smart orders. And then the market is going to take everybody's orders, cross supply and demand, and get the consensus of where people think the price should be, and then all trade takes place at that consensus price. That's how markets should work. It shouldn't just be a race to see who can be fastest. For the exchanges, they can actually, this enables the exchange to do computation. So they can elicit preferences from the traders in much richer ways. All these securities are interrelated. They want to do hedges and so on. Well, they can express that, and the exchange can solve the resulting optimization problem. And for the regulators, they can see what's happening. Today, we have market rules, for example, against front running, which is basically identifying you're making a big trade, and then I jump in front of your trade and stand between you and your trading partner and capture some spread. Well, front running, now, and this was the theme of Michael Lewis's popular book, Flash Boys, it basically is rampant. It's happening all the time, every microsecond, and the regulator can't see it. And the reason they can't see it is they can't see, there's no data that's at that speed. So this would enable the regulators to actually have market rules and enforce the market rules. So, why hasn't this, we've gotten a lot of support for this idea, but it's not been adopted. And the reason it hasn't been adopted is because people want to be convinced there aren't going to be unforeseen consequences that are undesirable. And so we need to have a prototype, and this is typical in market design, that a prototype is needed. Our plan now, and this is joint work with Axel again, is to build an exchange platform on Amazon Web Services where we simulate trading environments, but then real people, computer scientists, finance guys from business schools, come in with their algorithms and engage in trade. And then there's a reward for the trading profits and prize for being the best trader and so on. And this is really a very powerful way to demonstrate that it works, that it can be done, and we can explore a whole list of very important questions like market stability. Okay, this is a $1 trillion question. Because when the markets collapse, it does have real impact on the global economy. The market fragmentation, how markets evolve, and then the development of smart markets where people have rich ways of expressing preferences. So all these things can be done. So let me conclude with the slide you've already seen, which is we've got some of the boxes there checked off. Okay, they're not perfect, but we're getting, especially electricity in Europe, but it's getting better. We're nearly there. But the other areas still need lots of work. And it's not just saying the two words and it happens. It requires many, many years of dedicated research and building prototypes, demonstrating the ideas, making sure that it works as intended. All those things has to take place. And where are they taking place? They're taking place here at the center and other areas throughout the world, and it's really exciting for me to participate in this activity with all of you. Thank you very much.